Okay, so let's try this again. I recorded this one time and it only recorded the bottom of the screen and you couldn't see anything. So let's try again. Okay, so number 3, I think was one that you guys had issues with. Probably with the balancing because it's a little difficult. Combustion reactions can be hard. So I'm going to go through it hopefully how you started with it, and then we'll see what to do to fix it, okay? So you have 2 carbons to start and 6 hydrogens and 2 oxygens, all on the reactant side. On the product side, you've got 1 carbon. For hydrogens, you have 2, and oxygens, you've got 2 plus 1 to give you a total of 3. That whole separation thing makes things difficult, right? So we have to put a 2 in front of the CO2 to make it have 2 C's. 2, yeah. And then that makes this first number a 4 because the 2 O's times the 2 gives you 4. So that takes it to 5 oxygens. Then you put a 3 in front of water to make the 6 H's. But then that makes 3 for that section, so that makes a total of 7. And you probably got to this part and said, what are we supposed to do? Because we cannot make 7 oxygens on the left side. Okay? So when this happens, we just have to double everything. Because if you multiply by 2, then you're going to get rid of the odd number. That's what happens. So if I back up a little bit, let's restart. Okay. So currently we've got 1 carbon, 2 hydrogens, and then 2 plus 1 equals 3. Okay. So when I say multiply by 2, I'm saying this first one right here, we're going to multiply by 2. By doing that, we're going to double everything on the other side. Okay, so before we move to the other side though, that means that we have 4 carbons and we have 12 hydrogens. Okay, so I'm not going to put the numbers I put on the first round. I'm going to now put a 4 in front of carbon dioxide because that will give me 4 carbons. And then that changes 4 times 2 is 8 there, so that makes us have 9. Then go the H's next, so we need 12, and so I'll put a 6 in front of water, so that makes that have 12. And then there's 6 O's now instead of 1, so that makes it 8 plus 6 is 14. Now that we have an even number, because we doubled, now we can make it work out. So the coefficient half of 14 would be 7, so we would put a 7 right there. So combustion reactions are difficult to balance, especially when you have to do this number 2 in the front sort of thing. I think in a different email, you might have said that you were struggling with 5. Let me just make sure, okay? This one's already balanced. It's a decomposition reaction because you only have 1 reactant. And in that 1 reactant, we've got 1 zinc, and then the 2 goes to both the O and the H. So we have 2 of each of those, okay? Now on the product side, we've got 1 zinc. Now for O, we have 1 from the first plus 1 from the second to make a total of 2. And H there is 2. So that is an already balanced equation. Hopefully you guys got that figured out. The second email didn't say that one, but I just wanted to make sure that you got it. Okay, number 9. Number 9 is also a combustion reaction, and so this one is actually going to be similar on what we have to end up doing, like we did on number 3. So we've got the C4H10 gas plus oxygen gas is O2. We have to have O2 because whenever oxygen's by itself, it would really like to have that too. Then arrow, carbon dioxide, CO2 gas, plus water is H2O gas. Okay? So I'm going to just give you a little hint. Sometimes people need this hint to help them out. So on a combustion reaction, when you look at the carbon thing at the beginning, if you have an even number of carbons, so we have 4 here, then that means that we're going to have to do that double everything, multiply by 2, like we did on number 3. Because on number 3, we had 2 carbons. So that meant that we're going to have to double. Sorry, I just pointed at the H's. I meant to go right there. Sorry. So when you have an even number of carbons on a combustion reaction, then that means that we're going to do the doubling. We're going to put a 2. So that 2 will go in front. Now, I didn't really leave myself space to write it all out, so I'm going to just say it out loud. Okay? But by putting the 2 in front, we now have a total of 8 carbons. So I have to put an 8 in front of CO2. Don't worry about those oxygens right now. Let's just go back to H. So then with the 2 in front, we now have a total of 20 hydrogens. So I have 2 to begin with, so I have to put a 10 in front of the H2O. Okay, so now that we've got our carbons and our hydrogens to match, let's count up our oxygens. So in the first part, the CO2 with the 8 in front, 8 times 2 is 16. So we've got 16 O's from CO2. Plus, we've got 10 times 1, so 10 O's from H2O. So that is a grand total of 26 oxygens. So it's an even number because we did the doubling, and half of 26 is 13. So that big, like put the 2 in front trick, it really, really helps out. If you get odd number of oxygens, chances are that is what you do, is you would just put the 2 in front like we did there. So I hope that this helps out, and I hope you're not stuck anymore.